Okay, I'm just making sure everybody knows what correlation means. So insight with our bivariate data gives us R, which is our correlation thingamajig. So if there's a positive linear correlation, R will be positive. If it's 1, the correlation is perfect. If it's between 0.9 and 1, it's strong. 0.7 and 9, it's significant. 0.5 and 0.7, moderate. 0.3 and 0.5, weak. 0 and 0.3, it's not significant. You learn this off by heart, but it's not an exact science. If it's 0.5, is it moderate or is it weak? Moderately weak maybe. So it's like you can't call it strong when it's 0.3, but you might call it reasonably strong at 0.85. When it's a negative linear correlation, -1 is perfect. And basically the values stay the same, the sign is different. The negative sign just means it's going downhill. So what does this mean? Here we have an example of a correlation of 1. That means it's positive, it's going uphill. As x increases, y increases. And all of the points are exactly on the line. There's absolutely no error in this model. It's perfect. The predictions would be perfect. Here we've got -1. So the dots are all also exactly fitting on the line. However, it's going downhill. So if you have a person on skis going from left to right, they're going downhill. So it's negative. Okay, next. Now we can see that's nice and tight there, pretty tight here. So we can see that this is quite a strong relationship. It's not so strong there though, and that's why we can't always just trust the R. We've actually got to look at it and make our own judgment. So this says 0.96, so that's saying it's a really strong correlation. However, I'd be concerned that the model isn't quite so flash here. So that's why we have to use the eyes. It's going downhill, so it's -0.96 here. Okay, next. This one here was the same graph, but I just manipulated variables to get them to do what I wanted. This is 0.96, so it's the same kind of situation here. We've got these to worry about, but we know that we've got a strong positive relationship because 0.96 is more than 0.9. Okay, your insight gives you this kind of thing, so you can see these ones here. Well, that by that is there, and that's the same relationship with the different explanatory and response variables in a different spot. So that's the strongest, or these ones here look strong. That maybe looks not so strong. Those are all positive. I mean, what's this? Is that possibly a negative relationship, or is it no correlation? That here doesn't look like much correlation, no significant relationship. That looks significant, quite strong. That's got a bit of a shape this way, but reasonably strong. That doesn't look particularly significant, does it? That looks significant. That looks like possibly no correlation. So that's what you've got to see. You've got to use your eyes as well as these numbers. So choose a decent relationship to investigate, because how can you make predictions if there's not much of a relationship going on? Okay, so here we've got a correlation of 0.32. So that's only just a relationship. There's a weak relationship there. But look at kind of the shape of these points. It's like a fish shape. You know, it's quite a weak relationship. And you can see that this one's that bit stronger. And here, oh, sorry, it's not stronger. It's the exact same relationship, but it's on the negative. Silly me. Okay, this one here is a little bit stronger, a tad stronger. It's got a 0.4 correlation coefficient. It's 0.4 going uphill, so it's positive linear association, but it's a weak relationship. And here we've got a 0.13, no significant relationship there. Now this is a really good thing that you actually get to do it. Do this little quiz, and I suggest that you go to BBC Bite Size for scatter graphs. So here you can see it's going downhill, So we can see that there is a correlation that is negative. Okay, so there's a whole quiz there that I suggest you do. It's very nice. And these ones here, that looks like no real correlation at all. Okay, so that's the link to the BBC Bite Size, and that's the link also to Nayland Maths. This here is quite a nice diagram. So we've got -1, perfect in a line, +1, perfect in a line, but this is going uphill left to right, and that's going downhill. As x increases, y is decreasing. As x increases, y is increasing. Okay, here, no correlation. We wouldn't know which way to draw the line. Here, it's quite tricky to see where we draw a line there. Here we can see quite a strong connection. A weaker connection, negative here. And here we can actually see where to draw the line. So this is negative because we're going downhill, and these are positive because we're going uphill. Okay? And remember, state the obvious. Say, is it a positive or negative? Which one is it? Make a choice. Is it going positive, uphill, or negative, downhill? Is it increasing or decreasing? So if it's positive, therefore, as x increases, y increases. If it's negative, coming downhill, negative, then as x increases, y decreases. Okay? Is there a relationship or no relationship? So basically, remembering here is no relationship. This is a weak relationship. This is a significant relationship, and that's like a perfect relationship. A strong relationship would be 0.9. Here there's a relationship, but it's weak. Okay, so is there a relationship or not? Well, there has to be, otherwise you can't pass because you can't make a prediction. It's a linear relationship that we're talking about. You don't get an R or a correlation coefficient with your quadratic or your cubic models. So state that it's linear. For example, it's a strong, positive, linear relationship. So you've said the relationship, you've said it's positive, you've said it's linear, and you've said how strong the relationship is. And the next thing you have to talk about is as whatever is on the x-axis increases, what does the y-axis do? Does it increase or does it decrease? And you need to put that into context. So you need to name the variables and remember the units. Okay? Hope that's helped somebody.